Welcome to this explainer. Today, we are unpacking something absolutely fascinating. We're diving right into the glowing, mysterious black box of artificial intelligence. Look, as AI systems get more and more powerful, governing them responsibly, it isn't just a nice to have anymore. It's a hard requirement. And that's exactly where the ISO 42001-2023 standard comes in. Think of it as the ultimate global framework for managing AI systems transparently and securely. But it does raise a pretty big question. What happens when things don't exactly go according to plan?
Right. What happens when the black box breaks? When an AI system starts flashing giant warning signs for, say, data governance or transparency failures, you can't just reboot the server and hope for the best. You've got to become a detective. Whether you're an auditor or an AI manager, you really have to step into that investigator role. You have to figure out exactly what went wrong, why it went wrong, and most importantly, how to make sure it literally never happens again. So here is our roadmap for the investigation. First, spotting AI suspects. Second, the triage process. Third, the interrogation. And finally, number 4, closing the case.
All right, let's jump right into Section 1, spotting AI suspects, specifically identifying unique AI nonconformities.
Now, you might be wondering, how is this different from regular tech issues? Well, there's actually a stark difference between a traditional IT failure and an AI nonconformity. In traditional IT, a bug usually means the system crashes, or maybe a server goes offline. It's a binary failure. It works or it doesn't. But an AI nonconformity, that is fundamentally different and vastly more complex. We aren't just looking for software crashes anymore. We're on the lookout for things like algorithmic bias or opaque decision-making, where honestly, the AI works perfectly from a technical standpoint, but it produces incredibly flawed or unfair results. This hidden complexity is exactly why Chapter 12-1 of the ISO standard is absolutely vital. According to the standard, there are 6 major ways AI systems deviate from the rules. These are the specific red flags an auditor is hunting for. First up is non-transparency. If an AI makes a critical decision but acts as a totally opaque black box that humans can't even begin to understand, well, that's a major nonconformity. Second is bias and discrimination, where the AI's output is skewed or unfair. Third, data governance failures. If your training data is inaccurate, outdated, or just poorly managed, your whole AI is compromised. Fourth on the list is security and privacy concerns. This includes really unique AI vulnerabilities, like adversarial attacks, where bad actors essentially trick the AI with manipulated inputs. Fifth, we've got accountability and auditability issues, meaning there's literally no log or trail to prove how a decision was made. And finally, inadequate risk management, which happens when an organization simply fails to foresee and plan for these very specific AI dangers. To put that into perspective, let's look at what happens in the real world when those red flags are ignored. In our first case study, a financial loan AI was found to be rejecting minority applicants at a disproportionately high rate, even though they had financial profiles similar to approved applicants. So what was the root cause? It was trained on biased historical data. Under the ISO standards, this is a glaring nonconformity in bias, fairness, and data governance. In our second case, a healthcare diagnostic AI used for reading medical images was actually vulnerable to adversarial attacks. That means someone could subtly alter a medical image just enough to trick the AI into giving a complete misdiagnosis. Because the hospital lacked encryption and adversarial defenses, this was a massive security and privacy nonconformity. As you can see, unchecked AI has very severe real-world consequences. Moving on to Section 2, the triage process. This is all about classifying nonconformity severity. When an auditor actually finds one of these nonconformities, they don't just toss it into a giant pile. Every single issue gets classified into one of 3 distinct levels of severity. Let's break down these 3 levels so you know exactly how to prioritize them. First, we have minor nonconformities. Think of these as isolated issues with no immediate risk to the system. For example, maybe an auditor finds a missing employee training record in the finance department. Sure, it needs fixing, but it's definitely not bringing down the company. Second, we step up to major nonconformities. This is a systemic failure requiring prompt action. An example here would be an organization entirely skipping their scheduled infrastructure risk assessments. You can't just ignore that. And finally, we have critical nonconformities. These pose a severe immediate risk to safety, security, or legal compliance. A great example would be a misconfigured firewall exposing sensitive training data, or even a system using expired ingredients in an automated food processing facility. Critical issues, they demand an immediate, all-hands-on-deck response.
Now we hit Section 3, the interrogation, where we conduct root cause analysis.
Look, for an ISO 42001 audit, a quick patch is never going to cut it. You have to conduct a root cause analysis, or RCA. Simply put, this is the process of investigating the fundamental, systemic, underlying factors that led to the nonconformity, rather than just treating the immediate symptoms. If an AI system is biased, you don't just manually override the biased decisions and call it a day. You use RCA to figure out exactly how that flawed data got into your training set in the very first place.
To do this, an auditor opens up their toolkit. First, we have the 5 whys, which involves simply asking why repeatedly until you hit the foundational failure. Next is the fishbone diagram, also known as the Ishikawa diagram, which is great because it helps categorize causes into specific areas, like people, processes, equipment, and the environment. Then there's Pareto analysis. This uses data to identify the most impactful problems, often finding that 80% of your issues stem from just 20% of the causes. And finally, fault tree analysis, which works backward from a failure to logically map out every single contributing event. These are fantastic analytical tools that help an investigator pinpoint the exact origin of a breakdown. Which brings us to Section 4, closing the case. Time to implement corrective actions. Everything we've talked about builds into a beautifully structured 5-step corrective action process. Step 1, you identify the nonconformity. Step 2, you analyze the root cause using the tools we just discussed. Step 3, you plan the corrective action. Ask yourself, how exactly are we going to eliminate that root cause? Step 4, you implement the fix. But step 5 is arguably the absolute most important for ISO compliance. Verify effectiveness. You have to follow up and prove that your fix actually worked and the problem is gone for good.
And of course, in the world of auditing, if it isn't documented perfectly, it literally didn't happen. Corrective action documentation must be incredibly thorough. It has to include a description and evidence of the issue, the root cause findings, the specific actions taken, the responsible parties assigned to actually do the work, the timeline and resources required, and finally, that crucial verification of effectiveness we just talked about. Accountability is the absolute key to closing the case.
Which brings us to our final thought for today. Think about this. If your AI made a life-altering decision today about a loan, a medical diagnosis, or a job application, could you prove exactly why? ISO/ISO 42001-2023 isn't just a bunch of red tape or a checklist. It's the operational framework that ensures the answer to that question is always a transparent, fully documented yes. Thank you so much for joining me in this explainer, and keep asking the right questions about your systems.